Okay, well, actually, you need a second to get settled. Never mind. So you're really supposed to drink that today?
No, I don't know if we have to make the whole thing.
Yeah, I get it. Hey, good morning. No, you're okay. So you missed recording homework, and we'll talk. And there's something in your seat.
I was at the store and the kid in front of me is hard work.
Oh no, we'll talk. You're okay. So guys, allow me to bring you together here, and let's talk a little bit about how this is going to play out. I suspect you don't understand this, so let's talk. So Austin, join me. And guys, it goes like this. The quiz that you have in front of you that you are about to grade, but we're not going to record scores, this is completely diagnostic. It doesn't matter your score. It's not going in the grade book. But guys, what it is going to do is it's going to give you a sense of the things that you can't yet remember how to do. And then your responsibility between now and next Wednesday is to figure those things out, because you are going to have a little like mini test over this on Wednesday. It's going to look exactly like this quiz, different numbers, same stuff, and that will go in your grade. So guys, the deal here is as you grade this, you want to be marking these carefully so that you can figure out what you don't know, so that you can figure out what you need to review. Now, if you need to review stuff, guys, understand some of this is you just, oh gosh, I made some silly mistakes. If you need more support, if you go to Tuesday's day on our website, there are video links to tutorials. Feel free to use those. If you need more help, grab me, grab a friend, grab a math teacher, whatever you need to do. But it's go time next Wednesday. So take a look at the top of these. We'll sort of scoot through this, and then we'll get started. And it's Abby, right? Okay, we'll talk before we go. Oh, you know what I can do? While you guys are doing this, let me hand you these. Are you guys okay with the rounding stuff? Did y'all get that? Okay, so I'm gonna zoom out, and I'm gonna zoom in, and do my best to center this, and hopefully then you can grade the rest of these. And guys, while you're doing that, I'm going to give you your homework. We'll talk about it in a minute. Those are good looking. Oh gosh. Do you need a paper towel? I'm on it. Yep. Got it. So guys, you good here? Yeah? All right, so now the rest of this is actually on the back. So if you run onto the back, of course you're on that graph paper. And guys, this is what your graph was supposed to look like. Now, here's the problem. You don't know what of this is important, what of this there's room for freedom of expression, how much of this really needs to be the same. So guys, what I've done down below is I gave you 8 important things that have got to be present for your graph to be right. Let me read through them with you, and if any of these are not present in your graph, I would be writing all over that thing so that you have something to study off of when you're getting ready for Wednesday's quiz test. So guys, first of all, number 1, your axes need to start somewhere around your smallest piece of data. For time, that would be no time. For temperature, that would be around 10 Celsius. Guys, number 2, you need to label your axes, including units, temperature Celsius, time seconds. Third, your units on the axes need to be evenly spaced. So I went by 5s and then by 20s. That just has to be even the whole way across. Then guys, fourth, you've got to have clearly plotted points. Fifth, you need a descriptive title that allows you to identify what the graph is about. Sixth, the graph needs to be big. If it doesn't fill half the page, it's not okay. The reason is because small graphs don't allow you to identify trends. Seventh, and this is really important, guys, time has got to be on the x-axis because it is the independent variable, which is the one that you are messing with. And then temperature, the dependent variable, has got to be on the y-axis because you are figuring out how temperature changes with time. So temperature depends on time. So time is on the x, temperature is on the y. So guys, doctor up your graphs. Make sure that you got those 8 points. When you're all done, you can take this paper. I'm sorry I forgot to punch holes in it, but tuck it away in your notebook. And then guys, you need paper, pencil, calculator, and we'll get started in just a moment. Guys, typically as we grade homework, I would ask for questions. Do you need help on any of this? Understand I'm not doing that right now because your questions are going to be broad and varied, and you have those video links to help you answer your questions. Bless you. All right. You guys all caught up? Okay. It's okay if I go? Okay. So guys, here's the scoop. This is the way we will start class every day. When it's a day of lecture, I will always put the topic of the day up on the board, and that's your cue to make that the title of your notes so that when you go back to study for the test, you can go, oh yeah, the first thing we did in this unit is we talked about data and measurements. Then I'll give you the date. The date today is the 25th, and as you are struggling to stay organized, I will do everything I can to help you do that. So guys, today's the 25th. The topic for today is data and measurements. And then guys, the next thing that we'll do is I will lay out for you everything we're going to do in the day. I'll typically pause for a second and let you get everything caught up. But then guys, I will give you the picture for the whole day so that when we then go back to learn the stuff, you sort of have a sense of how this all fits together. You guys ready to go? You're good? Okay. So guys, this is the way this is going to go down. You may remember, you don't remember, the first day of school, you don't remember anything. That's why we don't go over disclosure documents. So guys, the big deal is this. Our goal for this unit is to get you in here and to help you be successful working in lab. Now you may remember that we talked about the idea that certainly that involves safety and it involves learning how to do calculations and graphing and things like that. Because it also involves learning how to measure well and communicate how well you measured. And that's what we're going to talk about today. So I got a question for you. How many of you have already taken physics? Holy buckets. All of you? Not all of you. Okay, so now let me ask you this question. How many of you have a deep-seated disgust, hatred for significant digits? All right, so guys, here's the deal. If you have a negative experience with significant digits, let me take a swing at this. But here's the other thing. If you got into physics, you don't know what significant digits are, you couldn't keep track of the 11 significant digit rules, and you finally just gave up, guys, give me a chance. I promise you I can teach this to you in a way that makes sense, which is in no way a slight against Miss Leosa. She's amazing. But I have a way of teaching this that's a little bit different that tends to connect with people. Now, guys, here's the thing. For the few of you that haven't taken physics, you start with a clean slate, which is awesome because I can teach you this material and you don't even know you're supposed to hate it because you've never had physics. So it'll be great. So guys, today what we're going to do is we're going to wrap up talking about significant digits. But we've got a long way to go before we get there. So here's the way this is going to go. First of all, we're going to talk about the two types of data. Then what we're going to do is we're going to push one of those types of data aside and we're going to focus on the other. And as we focus on the other, we're going to talk about how we communicate the quality of that data. Then what we're going to do finally is we're going to talk about how we communicate that in numerical form, and that's where significant digits comes in. So that's the scoop. Here's where we're going to start. You ready? And this goes in your notes. So today is all about dealing with data. And what you're going to find out, guys, is there are actually two different types of information that you're going to collect in this class. And it goes like this. Guys, the first type is what is called quantitative data. So gang, when you think of quantitative data, because you're all budding young English students, what is the root word of the word quantitative? Quantity, right? So that when you're collecting quantitative data, what you're doing is you're trying to figure out how much or how big. So this is derived from measuring and counting, and it always involves a number with units. So guys, when we go to do our first lab, which will be next week, as I'm introducing the lab to you, I'll get up here and I'll say, okay guys, today's lab is going to be completely quantitative, which means that all of the data you will be collecting will involve measuring in numbers and units. So you'll understand when I say quantitative, what's expected of you when you gather data. You get the idea? Is that pretty straightforward? Not too bad? Okay. So guys, if quantitative is one, let's talk about the other, and not surprisingly, that is what is called qualitative data. So if quantitative is quantity, qualitative is quality. And guys, when we say quality, we don't mean, hey, that's quality data. We mean it is qualitative in that it is descriptive and it's derived from observation. So what are the qualities of the things that I'm looking at? It involves adjectives: big, little, pretty, hard, green, soft, stinky. It's the things that you are experiencing and observing and describing. All right, so guys, we are at a stopping point. Do you get it? Questions, concerns, thoughts? You're okay? You're sure? You'd ask if you weren't, right? Okay. So guys, if you've got this all figured out, we're going to give you the opportunity to demonstrate that you understand what's going on. Obviously, don't try to write this down. But guys, what you've got here is actually a computer rendering of an organic molecule. The whites are hydrogens, the blacks are carbon, the yellow is sulfur. It's a big old organic molecule. Doesn't matter, it's just what it is. And then this green thing represents an enzyme that is attacking this bond, and it will eventually break the molecule apart. Here's the question. Qualitative and quantitatively, what kind of data can you collect from this picture? So guys, here's what I want you to do. In your notes, please do this. In your notes, please write down one quantitative and one qualitative observation from this picture. You said you understood it. Let's make sure. Once we're all comfortable that you get it, we'll go on from there. One quantitative, one qualitative. What's that, Zach? They're hydrogens. Yeah. That'll be great if you go that far. Black is carbon, yellow is sulfur. You guys okay? So let's try this. Devin. So give us a quantitative observation from this picture.
So, it might be more, but
Yeah. Beautiful. And I love that you sort of said, we're probably going to be close. But guys, let's think through this. I asked Devin for quantitative, and he said there are about 15 hydrogens. So does that qualify as quantitative? Look at your definition of quantitative and see if it fits. Did that involve measuring or counting? You bet. Does it have a number? You bet. Does it have units? Hydrogen atoms. So guys, he met all three of the qualifications, so that would be quantitative data. Do you get the idea? Okay, so Gwen, give me a qualitative observation. I'll bet you can do it on the fly. What does it mean to be qualitative? It's descriptive, so sulfur's what? Perfect. Sulfur is smaller than hydrogen, and actually it's not for real, but yeah. So, but let's think about it. Did she describe something that is true in the picture? Yeah. So, I mean, even on the fly, qualitative descriptions are just describing something that you see. The enzyme is green, the carbons or whatever it is are white. You're just describing something you see. Do you understand the difference? Is that okay? All right, so guys, let me throw you one more. Let's make absolutely sure, and then we can put this to bed. Forgive me, I didn't even think about this when I put this in my slides. It's Mountain View colors. Wasn't on purpose, I swear to you. But we've got a coach chewing out a football player, right? Quantitative and qualitative observation, one of each. Put it in your notes. One of each. That's annoying. You guys okay? Enoch, give us qualitative. Wonderful. Helmet's yellow. Qualitative? Did it describe something about what he's seeing? Absolutely. So qualitative observation would be the helmet's yellow, football player is wearing a yellow helmet. So Ryan, give us quantitative. Perfect. There's two P. Do you get the idea? Pretty straightforward. So guys, let me throw you a curveball. What about this one? Rather than ask you to give me a description, let me give you a description and you tell me which one it is, qualitative or quantitative. So if I told you that the football player's jersey has the number 24 on it, qualitative or quantitative? Uh-oh, now we're a split jury. Which one is it? Qualitative? Zach, explain it to us. But hold on, how can it be I'm setting you up. How can it be qualitative if it involves a number? Okay, so exactly, it's an observation, right? But go back to the definition of quantitative. Which of the three things did it fail? There was no measure. Yeah, and you say it. There's no measuring. There's no counting. Guys, in this case, the number is descriptive because it's not measured or counted and it doesn't have units. Do you see the idea? You're good? All right. So guys, we're ready, I think, as a group to move on. Let me zoom out. Let me switch. And guys, now we're going to shift gears. Check this out. You ready? Watch my hands. So we just figured out that qualitative is descriptive and quantitative is measured, right? Put qualitative in your pocket. We're done with qualitative now. So everything that we're going to do for the rest of the day is quantitative, measured numbers, units. So guys, now what we're going to do, and you want to put this in your notes, is we are going to talk about the quality of quantitative data. It's a little wordplay. Okay, so here's what I need you to do. Bryce, don't get nervous. I'm coming your way. So guys, what I need you to do is I need you to draw 3 bullseyes in your notes. Skip down 5 lines. And then you're going to draw 3 bullseyes in your notes. If they're an inch in diameter, that'll be fine. They don't have to be huge. But draw yourself 3 bullseyes and a little bit of space up front, up top, to take some notes. And you guys all understand this, right? If you're shooting at a target, whether it's darts or guns or bows or whatever it is, you're shooting for the red dot in the middle, right? Y'all understand? Okay. All right. So, guys, here's the thought. We put away qualitative. Now we're talking about quantitative data. And guys, the question now becomes this. What words do we use to describe the quality of quantitative data? So if I'm measuring something and I'm like, and I'm making a measurement, and if that measurement is really, really good, what words will I use to tell you that's a really good measurement? That measurement is really accurate. That measurement is really awesome. That measurement is really spot on. What are other words? Precise. What about exact? Guys, there's all these terms that we use to describe good measurements, but they don't mean the same things. So there are 2 words that we are going to use: precise and accurate. And they don't mean the same thing, and you need to know what they mean. So guys, here's what we're going to do. First of all, precision. Let me define it for you. Guys, precision, actually, you know what? We're going to do this different. I decided to switch this up. Now I'm coming back by Bryce. So guys, rather than define it for you, I'm going to have you come up with your own definition. So here's what I'm going to do. It's not really going to happen, but. So guys, what I'm going to do down here in this lower left-hand target, right? So label that in your notes, right? Precise down below it. And then guys, I'm going to squeeze off 5 virtual rounds into this target. And you want to put them on your target too. These 5 shots are going to be precise. You ready? There's 1, 2, 3, 4, 5. And guys, those 5 shots are amazingly precise. You'll notice none of them hit the bullseye, but they're amazingly precise. So guys, in your notes, jot a note to yourself, define precise. What does precise mean given these shots? Put it in your notes. Did you get something? Cade, can I hit you up? What'd you put? I love it. That's actually, you'll see I use similar words. Guys, that's all it means. It means that your data is repeating. Any other words that you guys used? So, say again, Nina. Consistent is a great term. The same every time, that's not a word, it's a phrase. But guys, bottom line is it means it's well grouped, or as Cade said, repeatable. But guys, it doesn't mean it's right. You can be really, really precise and just keep doing the same wrong thing over and over and over. For some of you, that's your life story. Dad, I'm not an idiot, I'm just precise. Try that. Never mind. All right. So guys, but you get the idea, right? Precision does not mean you're correct. It just means you're doing the same over and over and over. Okay. So let's now talk about accurate. And guys, now we're going to go the other direction. I'm going to give you the definition. Accurate just means correct. You're right. So guys, if you're shooting accurately, you're going to be right in the middle, right? So now guys, do this. Draw 5 accurate shots. Given the definition, draw 5 accurate shots into the middle target and label it accurate. I don't know why it makes me feel better to be back here when I draw the dots. I actually feel like I'm shooting. Is that weird? A little. Okay, so guys, you ready? You don't necessarily need to draw my dots in, but let me show you 5 perfectly accurate shots. You ready? You're probably going to be surprised. 1, 2, 3, 4, 5. Perfect accuracy. Never hit the bullseye. Can someone explain it? Go ahead, Enid. It's always right outside the bullseye. But what about this? Try this on for size. What if the shots did, let me switch to white. What if the 5 shots were over here? They would no longer be accurate. Do you see now? Say it again. Exactly. They are evenly spaced around the middle. And guys, if that doesn't make sense, try this. If we were to draw all of these into the middle equally at the same time, where would they all end up? Right in the middle. If you were to squeeze them down equally from all sides, they would end up right in the middle, which is actually a visual representation of what mathematical process? An average, right? And so if you were to take the average of all these points, they'd put you right in the middle. So guys, the take-home message from this is this. When you collect data, many times we will collect more than one data point and then we will average them, because averages, and you want to put this in your note, averages are always more accurate than individual pieces of data. All right, so now we've got accurate, now we've got precise. So when you collect data in this class, which one do you want to be? Do you want to be accurate or do you want to be precise? Both. You'd like to be both accurate and precise. Why accurate? You're correct. Why precise? So you're correct the first time. You don't have to do things over and over and over again. You'd like to be both. So guys, down here, do this. Write both and then fire 5 shots into that target. Oh gosh. All right. You guys ready? You got your 5 shots? You ready to see my 5 shots? They go like this. 1, 2, 3, 4, 5. Where's my 5 shots? They're all through the same hole. Guys, that's our goal. Seriously, that we want, sorry, this is weird. We want to be like the snipers of the chemistry world. We want every bullet to go through the same hole. The idea is that every time we make a measurement, we want it to be the same as the other measurements, precise. We also want it to be accurate. We want it to be correct, and we are going to learn over time how to make measurements like this. It's right and it's the same every time. You get the idea? All right. So guys, here's where we're at. We started with accuracy and precision. We didn't. We started with qualitative and quantitative. We put qualitative away. We talked about quantitative. Now what we've done is we understand that quantitative data needs to be accurate and precise. You with me? We're almost done. Accurate and precise. Now what we're going to do is we're going to put precision away, repeatability, and we're going to talk about accurate to round out the day. So guys, now what we're going to do is we're going to talk about how do we communicate the accuracy of data. So this is the next and last thing in your notes. How do we communicate the accuracy of quantitative data? The accuracy of measurements. All right, so guys, if we're going to talk about the accuracy of measurements, the first thing that we need is we need something to measure. So I used to do this by holding up this yellow chunk of plastic, and I would actually measure it using this meter stick, but no one could see. So I actually digitized it and put it up here. So here's the idea. This is our yellow chunk of plastic, okay? We'll call it a line. It's really a rectangle. It doesn't matter. But there's our yellow chunk of plastic. Now, guys, if we want to measure the length of that chunk of plastic, what do we need in order to make the measurement? You need a measuring thing, right? And if you're going to measure length, you need a ruler, or in this case, a meter stick. So instead of showing you this, which is broken up into 10 centimeter increments, I'm just going to do it digitally. You get the idea? So it's kind of like this is this end, and this is 10, and then 20 would be over here, and 30. And I sort of just expanded this so you can see. Okay, so guys, what we're going to do is this is 10 centimeters, and we're going to measure the length of this meter, or of this yellow thing, in centimeters. So in order to do that, what do we have to do first? Put the object on the meter stick, right? And we want to line up the zeros. So we move this over here, and now our object is on our meter stick. So now, guys, we need to measure how long this yellow thing is. How long is it? How many centimeters? It's 10. Now, guys, here's the trick. If you just write down 10, you're not necessarily correct. This is important you understand this. The rule is this, and you want to write this down. This is critical to you throughout the year. Guys, when you make measurements, you will always estimate 1 decimal place past the scale of the device. What on stinking earth does that mean? I'll show you. But you always estimate 1 decimal place past the scale of the device. So guys, do this with me in your brain. You ready? What is the scale on this measuring device? Tens. It goes 10, and then there'd be 20, and then there'd be 30. And so this thing is broken down into tens. So we have data in the tens place. So if we have data in the tens place, what is 1 place below tens? Ones. Does that make sense? You go ones, tens, hundreds, thousands. So if we have a scale to the tens place, you will estimate to the ones place. So looking for ones, is this yellow thing 9 centimeters long? No. Is it 11 centimeters long? It is not. It's 10. So we know to the ones place that this thing is 10 centimeters long. So all we're going to do, and you don't need to do this in your notes, is we're just going to say it's 10 centimeters long. You get the idea? But can we do better? Guys, if we want to know the length of a piece of plastic, can we measure it better than to the tens? What do we need? Smaller units, right? Can we measure better with this than we did with this? Of course. So let's get this out. And now this is broken down into the ones. So guys, if this is broken down into the ones, where will we estimate to? The tenths. Does that make sense? Always one smaller. So let's move this down, and now let's estimate tenths. Is this 9.9 centimeters long? Is it 10.1 centimeters long? No, it's 10. But how do we tell the world that it's not just 10, but it's 10 accurate to tenths? We looked for tenths and just didn't find any. What are we going to write down so that everybody knows we looked for tenths and they're not there? 10.0. Does that make sense? Is that okay? All right, but again, and you know where this is going, can we do better? Break it down more. So now we're broken down into tenths. So guys, if we're broken down into tenths, what will we estimate to? Hundredths. So we bring this down, and now we're looking for hundredths. So is this 10.01 centimeters long? It is not. Is it 9.99 centimeters long? It is not. It's 10. But if it's 10 and we look for hundredths, what are you going to write down? 10.0. You get the idea, right? Okay. Now, guys, don't miss this. You ready? I'm going to play with your brain a little bit. Don't miss this little word thing I'm about to do to you. Guys, let me ask you some questions. 10 and 10 and 10. 3 pieces of data, quantitative data. We're going to call this top, middle, and bottom. Guys, which of these measurements is bigger? I'm tricking you. Which of these measurements is a bigger number? Do you understand they're all the same? They're all 10, right? Okay, are you, yeah? Okay. So guys, all of these measurements have the same value. They're all 10. Here's the next question though. If none of them is bigger, which one of them is better? Which is more accurate? Top, middle, or bottom? Bottom, right? Now guys, think about this. What is it that allowed this measurement to be more accurate? A better measuring device, right? We had a better measuring device here, so we know that that number is better because it was recorded from a better instrument. Is that okay? Okay, so if you understand that, imagine this. Imagine if you never got to see any of this and all you were given were the numbers. If you were just given 10 and 10.0 and 10.00, would you still know that this number is more accurate? How would you know? What about this number tells you that it's more accurate? Do you see that it's the zeros at the end? What do these zeros tell you? That we looked for tenths and we looked for hundredths and we didn't find any. Now guys, listen really closely here. Guys, are these zeros important? Why are these zeros important? Well, if they weren't there, this number wouldn't be any better than that number. So these zeros are important because they communicate accuracy. You okay with the idea? So guys, I would propose to you that these zeros, check this out, these zeros are not just important, they're significant. Do you get it? Guys, that's all significant digits are. All a significant digit does is tells you accuracy. They're not evil, they're not yucky, they're not even hard to figure out. Guys, that's all a significant digit does is it tells you the accuracy of the measurement. That's it. Don't overthink this. That's all there is to it. All significant digits do is tell you accuracy. So guys, if you came into this class with a negative sort of impression of significant digits, don't overdo it. That's all there is to it. That even rhymed. Guys, seriously, that's all they do is tell you accuracy. And that's important enough. Let's put it in our notes. Guys, all significant digits do is communicate accuracy. Now, I know that you understand this, that if that's the case, then you've got to be able to tell which digits are significant. So guys, how many different kinds of significant digits are there? Like 11, right? From physics, you're like, oh crap, there was like 11 different rules. I don't really know which is up and which is down. And I tried to memorize them and I gave up and I never really understood them. And oh my gosh. And because you understand there's only 3 stinking kinds of significant digits. That's it. There's 3. If you can keep, actually, and the first one's stupid. So if you can keep track of 2, you've got this all figured out. So guys, I'm going to give you 4 rules for significant digits. The first one's easy, the second 2 are going to make a lot of sense, and the third one's unnecessary. You ready? Let's do this. So guys, you need to write these down. These are the rules for significant digits. But guys, understand, I will never ask you to regurgitate these things. You will never write down the significant digit rules. If you can identify what digits are significant, that's all you got to do. So here you go. Rule number 1, non-zero digits count. If it is not a 0, it's significant. That's 1 through 9, right? So for those of you that haven't taken physics and haven't done significant digits, guys, the bottom line here is you've got to be able to identify how many significant digits are in a number. Don't write down the examples, just watch. So 96 grams, how many significant, you don't need to write that down. How many significant digits? 2, the 9 and the 6. What about 61.4? How many significant digits? All 3. What about 0.52 kilograms? How many significant digits? It is 2, but what about the 0? We don't know yet. Because guys, all this rule does is it tells us about the not zeros. So guess what rules 2 and 3 are about? The zeros. And guys, you're going to find out that 0 is not significant. So what zeros are? Rule number 2. Final zeros after the decimal place count. So what on stinking earth is a final 0 after the decimal point? Well, what does it mean to be final? It's at the end. It's clear on the right. What does it mean to be after the decimal? Well, it's to the right of the decimal. So it's got to be both. It's got to be on the right of the decimal and at the end of the number. So guys, check this out. 10 centimeters. Is that a final 0 after the decimal? No. Is it final? Yes. Is it after the decimal? No. What about 10.0? Is this, the one on the right, is it a final 0 after the decimal? You bet. What about 10.00? Are those 2 zeros final zeros after the decimal? You bet. But guys, do you remember these are the numbers we came up from our measurements? This is what we did with the rulers just a minute ago. And now we can see by the rules that those zeros are important, and you learned that a second ago from capturing the data. So now, guys, the last question is this. What about those zeros? The ones that are on the other side of the decimal, are they significant? And the answer is yes. The reason is rule number 3. Rule number 3 says this. Trapped zeros count. So if you've got one or more zeros between other significant digits, those dudes are trapped and they count as well. So what about this? Is that big enough? Bryce, can you read that? Oh, good. I'm glad you guys aren't as old as me because I can barely read it from here. So guys, 5092. The 5, the 9, and the 2 count, right? What about the 0? Why? Between the 5 and the 9, and it's trapped. What about this? We know the 8, the 3, and the 5 count. What about these zeros in here? Are they trapped? They are. Between the 8 and the 3. And guys, understand that the decimal place doesn't matter, and they are trapped. Groovy? So what about this? Guys, the last rule then, don't even write it down. You don't need it. Because guys, what does rule number 4 say? Nothing else counts. You're done. You don't even need to write it down. There's only 3 kinds of significant digits. Non-zeros, final zeros after the decimal, and trap zeros. Is that so bad? You're okay? All right. So guys, let's do this. If you're concerned that you're not going to have anything to do over the weekend, it's the first weekend, summer's over, you don't quite know what to do. Let me offer you this as maybe you could gather your family around the computer. Fun for the whole family. Guys, here's the scoop. This is embedded in your notes if you printed the notes. If you go out to this website, check it out. Unlimited significant digit practice. I know. Gather your siblings together. This is actually great for family home evening. Just saying. So, whoever wrote this, good heavens. All right, you ready? New number. 0.0067. But guys, there's some value to this, right? The 6 and the 7, are they significant? Yeah, rule 1, they're not zeros. But guys, what about those zeros? Are they final zeros after the decimal? No, they're after the decimal, but they're not final. Are they trapped? No. So are they significant? No. So how many significant digits? 2. So here's what you do. You type 2 and you put check answer and it says correct. I know. All right, so, but guys, seriously, what about, oh gosh, I should have kept that one. That was a good one. What about this? Are those zeros significant? Yeah, because they're final zeros after the decimal. What about those? Are those significant? They're not final, so they don't count. What about, ooh, there's a good one. What about this? Are these zeros significant? They are not, because they are after the decimal, but they're not final. What about that dude right there? Why is that significant? Good, it's trapped. Okay, so now guys, let's try one more, and this is a great example. Guys, what this is saying is actually this. This is calculator language, but what this number is actually 5.5 times 10 to the negative third. How many significant digits are in that number? It's actually just 2. Guys, the deal is this. When you're doing significant digits for scientific notation, you only have to look at this part of the number. Why is that true? Well, watch this. Let's write it out. 1, 2, 3. This is that number written out. It's 0.0055. Are those zeros significant? They're not. You ready for an interesting thought? Guys, when you put numbers in scientific notation, what you're actually doing is just using this to represent all the non-significant zeros. How about that? No one told you that before. So guys, when you're doing numbers in scientific notation, you just got to look at that part. You good? All right. So guys, we are 4 minutes from done. Here's what we need to do to wrap this up. Not that. We need to do this. So guys, what I need you to do, if you would please, is write down these 6 numbers. Don't write down the parts in parentheses. Just write down the numbers, 3 on a line. And we're going to mess around with these, and then we're going to, holy smokes, you guys are probably going to get done with your homework, so you won't have homework over the weekend. That'll be okay. Do we have like 2 football games this weekend? Is that the case?
There's 3.
We play 3?
No, we could win with 1.
Oh, okay, but there's like teams coming for like an invite or something?
Yeah.
Oh, but we only play 1.
Invitational.
Nice. I like
So
it.
there's like Taylorsville, and we play East.
Oh, nice.
Yeah.
Yeah, okay. But Salt Lake East, like East High from Salt Lake? Okay. What? Say that. Oh, that's it. That's exactly where it is. So guys, again, please just write down the digits of these numbers. Don't write down the stuff in parentheses. But let me tell you right now, this is what your homework's going to look like. So let's make sure you can do these. Can we take a swing at them? Okay, so what we're going to do is I'm going to do the first 2 for you. Then I'm going to turn you loose on the last 3 and give you a minute to do them on your own. Well, the next 3. And then I'm going to do the last one with you because it's a tricky bugger. So here we go. Guys, looking at this first number, how many significant digits are in that first number? 6, right? There's no zeros, so they all have to count. Now, what you're being asked to do right here is round it to 4. You see what we're saying? So we've got 1, 2, 3, 4 significant digits. So we are now going to round this number to this place. So, and I know this is on your quiz. This is a good rounding review if you weren't comfortable with it. Guys, what does that 2 tell us to do? Do we round up or do we round down? We round down. So check this out. We're going to go 3. You know what? I want to move this up. We're going to go 314.7. So the 2 told us to round down, so we leave that as 7. Now, guys, check this out. What do we do with the 2 and the 1? Do we replace them with zeros or do we just make it go away? Well, look at what happens. If we replace it with zeros, what's true of those zeros? They're significant, and now we're back to 6. So guys, when you are rounding numbers that are below the decimal place, you do not replace them with zeros, you just cut them off, and that's 4 significant digits. Ask questions if you need. So, oh, yeah, please.
Wait, so there's 6 in that figures, their answer does not be that.
And that's the idea, because what we've done is we've taken 6 and rounded to 4. Because it asks us to do that. And what you're going to find out is when we start doing math with this stuff, you're going to be rounding your answers to the number of significant digits as the least accurate part of your measurements. So that's kind of where this is going. So guys, next number. How many significant digits in that guy? Are those zeros significant? They're not. They are after the decimal, but they're not final, so they don't count. So this has got 4 significant digits, but we want to round it to 2. So we've got 1 significant digit, 2 significant digits. Then we look at the next place, and it's a 7. What does the 7 tell us to do? Up or down? Round up. And so this number would be 0.0018. And that is 2 significant digits. You know what, guys? I actually changed my mind. I want to do the third one with you as well. Is that okay? Doesn't matter. I'm going to do it anyway. All right. So, guys, it goes like this. Is that 0 significant? Yeah, it's trapped, right? So we've got 1, 2, 3, 4. They're all significant, but we want to round to 2. So what does the 9 tell us to do? Round up or down? We're going to round up. So we're going to go 8 and 1. Now what do? Do we replace those with zeros? And the answer is absolutely. Why? Well, guys, check this out. If we put these zeros in, are they significant? They're not. So the idea is that leaving those zeros off would radically change the value of the number. It would turn 8100 into 81. So we've got to leave those zeros there, because if we don't, it changes the value of the number way more than rounding should. Groovy? Okay. Should we just do the rest of them together? Is that all right? So, guys, let's take a swing at this one. Pretty straight. Let's make sure you're clear, though. How many significant digits in that guy? There's 5. The exponent doesn't count. There's 5. So we want 3. 1, 2, 3. What does the 2 tell us to do? Down. So we're going to go 4.36 and then add the times 10 to the negative 5th, and there's our number. Not bad. Now, guys, what about the next one? Are the zeros in the next example significant? Both of them? Why? They're trapped. So now we need 3. And we go 1, we go 2, we go 3. What does the 7 tell us to do? Round up. So we're going to go 80.1. And then do we replace the 7 and the 3 with zeros? No, because they would be significant. So that's our answer. Good? All right, now check this one out. You're not going to like this, but it's pretty good logic. Guys, how many significant digits in 1040? 3. That 0 is significant because it's trapped. That one's not. Now we need 2 significant digits. 1, 2. What does the 4 tell us to do? Down. So we go 1, 0, and then 0, 0, and that is what we end up with when we try to round to 2 significant digits. Do you see the problem? Yeah. It's only 1. See, guys, this 0 was significant because it was trapped, but when we round the 4 down to a 0, that's no longer significant, it's no longer trapped, and now we've only got 1. So, guys, we've got to figure out a way to make that 0 significant. Does anyone know how to do it? Go ahead. Put it in scientific notation. We go 1, 2, 3, and we go 1.0 times 10 to the third, and now that 0 is a final 0 after the decimal, and it's significant. Pretty tricky, huh? But that's what you do. So, guys, here's the scoop. Grab your homework. Did you notice how heavy this is? This is your homework for the entire unit. This is not for today. No, I know, right? No. I will always give you every homework assignment for the unit for the entire day, and then if you look at the very last page, it's the test review. Okay, I gave it all to you. But guys, here's the way this goes down. See the number at the top of the first page? Then you'll know when you turn to the back, there is not a number 2. But when you look at the third page, there's the number 2. That means this is the first assignment. This is the next assignment. So your homework for today is just front and back. Okay, so let's talk about it. Let's do the first one together. Guys, upper left-hand corner, determine how many significant digits are in 71. How many? Write it down. You're going to do that for all of them. Now, guys, go down to the bottom of the page and notice what it says. Rewrite the numbers above representing the requested number of significant digits. So if you go to the upper left-hand example, there's a number 1 in parentheses. So what that's asking you to do is round 71 to one significant digit, and the answer would be 70. Good? Do that for those. Guys, then do the back. One other thought before I turn you loose on this. You got 20 minutes. You'll probably get done. This is a great time to grab your cell phones. Guys, all the answers to all the homework assignments are posted online. If you have a web-enabled phone, whether it's wireless data or connected to our network, doesn't matter, you can pull up all of the homework solutions on your phones and have the answers as you're working on your homework. If you don't have a web-enabled phone, the answers are tagged right here, and you're welcome to come up and check as you go. Guys, we got 20 minutes. We're going to spend this time productively getting this done. If you have questions, please let me know. I'd love to help. You're welcome to work with other people so long as it's productive, and that'll do us. Let's get this stuff done so you don't have homework.